Hi guys, so this lesson is an extension of 4.1 where we looked at all the different pieces of a quadratic when it was given to us in vertex form. So the first task that we have for today is we want to identify the same kind of things, the vertex, axis of symmetry, max or min at its value, and the range from this thing that's now called standard form. One other thing that we're going to add in there is how do you also find the Y-intercept. All right, second task that we have for today is what if I am given a quadratic in standard form? How do you change it over to vertex form? So the first thing we need to address is what is this thing that is called standard form? Standard form is f of x is equal to ax squared plus bx plus c, where a cannot be equal to 0. If you think about it, if a is 0, that makes the squared or the quadratic piece disappear. 0 times x squared wouldn't be an x squared. All right, so we would just end up with a line then. So the first thing that we want to be able to do when we have a particular parabola or quadratic that is in standard form is you want to identify what a is, what b is, and what c is. Okay? Now the second bullet there says if a is greater than 0, it opens upward. If a is less than 0, it opens downward. We already talked about that. But remember what this tells us. If a is greater than 0, that tells us we're dealing with a min. And if a is less than 0, that tells us we are dealing with a max. All right? So here's kind of a big difference right here. Is we've got this thing that is the formula, if you will, for the axis of symmetry. We are going to be using this a lot in this lesson. This x is equal to the opposite of b over 2 times a. This not only gives us the axis of symmetry, but it also gives us the x-coordinate of the vertex. To find the y value of the coordinate, or the y value at the vertex, what we do very simply is we substitute it back into the equation. All right, you'll see me do this a few times. All right, so one other thing that's new here is this idea of a y-intercept. And the y-intercept is always, for a quadratic, always going to be 0c. It's 0, comma, whatever the constant is of the quadratic. Okay, so what we're going to do now is we're going to do a few examples together. Okay, do your best to follow along. Hopefully this is going to be good enough. We can always finish up by looking at these things a little bit more next class. All right, so the first thing that I want to do is identify all these things. Vertex, axis of symmetry, max and min, blah, 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 from a particular quadratic. All right, so let's start with this quadratic. Let's say that we have 2x squared minus 6x plus 3. Now, I recognize that x is being squared, so I know it's a quadratic. I know this is in standard form because from here I'm able to identify a is 2, b is negative 6, and c is 3. Automatically, I can identify those things. All right, so from this information, what do I know about this quadratic right now? Well, the first thing that I know is this is going to be a smile. All right, I know that a is positive, which means it opens upward, and that gives me a wealth of information right there. Okay? The key for this, I have to first find this thing called the axis of symmetry, the A of S. All right? To find the axis of symmetry, I use the formula x is equal to the opposite of b over 2 times a, which gives me 6/4, and I would reduce that to 3/2. So I know for sure that the axis of symmetry is this vertical line at x is equal to 3/2. Okay? To find the vertex now, I'm going to take 3/2 and substitute it into the original equation. All right? I'm going to do that in red over here to the side. So I have 2 times 3/2 squared minus 6 times 3/2 plus 3. All right, so 3/2 squared, well, that's going to be 2 times 9/4 minus 6 times 3/2 plus 3. And then let's see what I get here. I have 2 times 9 is 18 divided by 4. Well, that would be 9/2 minus 6 times 3 is 18 divided by 2, so that would be minus 9, and then plus 3. All right, so I've got 9 halves minus, I'm going to change these all to halves just to make it easier to work with, 18 halves plus 6 halves. All right, and that would give me, let's see, 9 minus 18 is negative 9, plus 6 would be negative 3 halves. This information together tells me that I have a vertex at 3 halves, negative 3 halves. All right? So again, I found the axis of symmetry. I found the vertex. What are some of those other things that we had to find? Well, I know from my picture that this is going to create a min for me. I know that that min is going to occur at the vertex, and specifically the y value of the vertex, just like yesterday. So I know I have a min at negative 3 halves. Okay? The next thing is, we all know the domain is going to be all real numbers. Well, what about the range? So our range here is going to be, because it opens upward, y is greater than or equal to, and because it has a minimum value at negative 3 halves, it's going to be everything greater than or equal to negative 3 halves. The last thing that we're going to include here is this idea of the y-intercept. Now the y-intercept, by definition, is 0c. So in this case, it's going to be 0, 3. Now, this is all the information that we have to do for these problems. And if you think about it, what this would allow me to do then is this would allow me to graph this quadratic by using this information. The vertex, the axis of symmetry, whether it opens up or down, and the y-intercept. All right, so let's take a look at another example here. All right, example number 2. Let's say that we have the equation negative 3x squared minus 4x plus 6. All right, and I got to find all my details that I can about this quadratic. Well, the first thing I'm going to do, because it's quadratic, I'm going to identify a is negative 3, b is negative 4, and c is positive 6. I'm also going to identify that this opens downward. Well, that was pretty bad. But that opens downward because that a value there is negative. All right. First thing I want to do, x is equal to the opposite of b over 2 times a. So this is going to be positive 4 over 2 times negative 3, which would give me 4 over negative 6, or negative 2/3. So that tells me that the axis of symmetry is x is equal to negative 2/3. Okay? Now to find the vertex, I know for the vertex that the x value is negative 2/3. But now I got to go find the y value. To find the y value, I substitute back into the quadratic. So I have negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6. All right, so let's see, this is negative 3 times 4/9 minus 4 times negative 2/3 plus 6. Now when I multiply here, I have negative 3 times 4, which would be negative 12 over 9. Negative 12 over 9, which I could simplify. Let's see. If I write that, I know that both of them are divisible by 3, so this would be negative 4/3. Plus, I have negative 4 times negative 2, which would be 8/3. Plus, I'm going to go ahead and write 6 as 18/3, just to make my life a little bit easier, and this gives me 22/3. All right? So I know the y value at the vertex is at 22/3. All right, so I've identified the axis of symmetry. That's what this first thing was. I've identified the vertex. Now I've just got to spit out a few more details. All right, because this opens downward, I know that this is a max, and I know that the max occurs at the y value of the vertex, which would be 22/3. I know that the range is going to be y is less than or equal to 22 thirds. And I know that the y-intercept is always going to be the point 0c, so that's at 0, 6. Okay? Now, the last thing that we got to do today is to basically do the same thing, but now what we're going to focus on is how do you change from standard to vertex form. All right? So let's remember what vertex form was from yesterday. It said f of x is equal to a times x minus h squared plus k. But if you remember, the h and the k we determined by thinking about the vertex and how the vertex was moved around and identify it from that way. Now the a value right here is exactly the same as the a value in standard form. All right? So in order to change from standard to vertex form, there are two things that I need. All right? The first thing that I need to know is I need to know what is the vertex. We just got done figuring out how to find the vertex. You use the formula x equals the opposite of b over 2a, plug it in to find the y value. Okay? And then the second thing that we need to know is what is a. And that's going to go slap down right in the front of that. So let's look at a couple examples of this and then have you guys try to work on these on your own. So let's start with negative x squared plus 4x minus 5. And they want me to change this from standard to vertex form. First thing, anytime I'm dealing with changing from standard form, a is negative 1, b is 4, c is negative 5. Identify the a, b, and c. Now, I know, whoa, that kind of got a little crazy there, didn't it? I know that x, to find the vertex, I got no x. Well, that's the opposite of b over 2 times a, which would be negative 4 over negative 2, or an x value of 2. If I take that 2 and substitute it in, I have the opposite of 2 squared plus 4 times 2 minus 5, which would be negative 4 plus 8 minus 5, or negative 1. So right now, I know that I have a vertex at the point 2, negative 1. I also know that I have an a value of negative 1. With this information, I am ready to write the equation. My equation will be y, or f of x. Let's write f of x just to look a little bit more sophisticated. F of x is equal to negative 1. That's my a value. So again, remember, I'm using this right here. Negative 1 times x minus h, well, that'll be x minus 2 squared minus 1. And that minus 1 came from the y value at the vertex. There's my equation of the exact same standard form, but now written in vertex form. Okay, let's try one more of these just to make sure we're good to go. So for example, let's say that I have 2x squared minus 3x plus 2. Identify a is 2, b is negative 3, and c is 2. First thing that I have to do is I have to find the vertex. X is equal to the opposite of b, which is 3, over 2 times a, which would be 3/4. So right now, again, at my vertex, I know that I have 3/4 as my x value. I have to substitute that in to find the y value. So I have 2 times 3/4 squared minus 3 times 3/4 plus 2. This would be 2 times 9/16 minus 9/4 plus 2. And let's see, this will simplify to 9/8, and I'm going to change this 9/4 into eighths. All right, so that would be 18 eighths, and I'm going to change this 2 in eighths as well, plus 16 eighths. All right, and if I add those together, I get negative 7 eighths. Double check me on that. Let me see, that's negative 2. It's not negative, it's positive 7 eighths. Positive 7 eighths. Okay, I know that the a value is 2. I'm ready to write the equation. F of x is equal to the a value, 2, which is a stretch, times x minus 3/4 squared plus 7 eighths. And this is known as vertex form of this original quadratic. All right, so what I would like you guys to do now is work on Math Excel 4.2, all right, and help each other if necessary. All right, I know this is a little bit different, but do your best with this. Hopefully it works out okay.